Hello everyone, welcome to LimeGuru channel. In this video we will learn about MongoDB. And here is the agenda. We will discuss about what is MongoDB. Then we will talk about what are the features and benefits. We'll learn about the basic terminologies which we will refer in this tutorial. Then we will discuss how you can model your data in MongoDB. Then we will discuss about some basic database operation like what all you can do in MongoDB and what all you cannot do. We'll talk about aggregations, indexing, replication, sharding, capped collections, and rockmongo. So let's start with the first topic, which is what is MongoDB. Let me write down here what is MongoDB. So MongoDB, it's a NoSQL database. It's a NoSQL database which helps you to store your JSON based documents. So you can store your documents in the NoSQL database. And when I said you can store your documents, you can store any type of document. Any type of document. You don't need to define any schema you don't need to have any pre-built schema within your MongoDB. You don't need to define any relational mapping within the fields of your documents compared to the tables in the MongoDB. So you can store any type of document. Let's say today in document 1 you have certain fields, which is let's say field 1, 2, 3, and tomorrow in another document you have field 4, 5, 6. You can store all these type of documents within your MongoDB and you don't need to define schema. So it's a schema-less database. It's a schema-less database where you can store your unstructured or semi-structured data in the form of a JSON documents into the database. So this is, as I said, this is NoSQL database, so it will fit into those use cases where your schema is very dynamic. You don't have a predefined schema and your document structure keeps on changing. You can store all those documents within MongoDB and then later on you can query those data. You can query those documents based on different fields, and we'll discuss about how you can query in the subsequent video. But just wanted to tell you that what MongoDB is. So it is a NoSQL database which can store your documents, which does not have any predefined schema associated with it. So it's a schema-less database, and then once your documents are stored, you can query the data. You can update the data in the document directly. So this is the concept of MongoDB. Now we'll discuss about certain features and benefits of MongoDB. Features and benefits. So if I talk about features and benefits, the first thing I mentioned it's a database to store documents. To store documents. You don't need to have schema associated with those documents, so it's schema-less. So because of the schema-less, one of the added benefit is that you can store any type of document. You don't need to change your table. You don't need to alter your table like in relational database. If you have to add any extra field, you need to alter your table, add that column, and then only you will be able to save it. But here it's a schema-less database. You can store any type of document. You can scale this database. It's a scalable database. So you can scale this database for any amount of data. So if you have a need for storing big database requirements, you can opt for MongoDB and you can store those documents within MongoDB. So that is also one of the benefit, that it's a scalable database. Another benefit is that you don't need complex joins here to run your queries. So because the data is already in the form of a document, whatever document you have, you are storing it in a denormalized, you are storing it, the document as it is, right? So let's say if you have employee, let's say employee table, and let's say employee can have address, department, the basic details. So let's say employee can have name, ID, name, then it can have address. Then address can in itself, it can be a list of addresses, person, mailing address, shipping address, the current residential address. There could be multiple type of addresses. So address is there, and then departments are there, right? So department, let's say department can also be a list of departments where an employee can belong to multiple departments, for example. So the complete document, you can store it in the MongoDB as it is. But in relational database, you would have to store address in a separate table, department in a separate table, which would require a join if you want to fetch the details. But in MongoDB, you can save your nested document also as it is, and that's why you don't need complex joins, and that's why the data query would be faster as compared to relational database, because of the kind of documents and the way you are storing the documents is different from how you do it in relational databases. So these are certain features and benefits. You can store any kind of document, it's schemaless, it's scalable, and you don't need any complex joins within MongoDB to fetch the data, and that's why it's faster. Now we'll talk about certain terminologies in MongoDB. So let's talk about certain terminologies, and we will compare it with relational database also. So in MongoDB, in relational database, let me write down here. I'll make a comparison also, RDBMS and versus MongoDB. So in relational database, whenever you have to make any new database, it is called a database. You can create multiple databases, and within those multiple databases, you can have multiple tables, right? So this is the terminologies in RDBMS. So in MongoDB also, if you can create multiple databases on here also you can create multiple databases, but inside those databases, when you are going to create a table, so that table is called a collection. So in MongoDB, it is called a collection. So, and inside the table, you can have multiple rows, right? In RDBMS, you can have multiple rows inside the table, but in MongoDB, you will have multiple documents inside the collection. Inside the rows, you will have columns, and columns will have a value, right? In MongoDB, inside the documents, you will have fields, and inside the fields, you will have value. So now you can relate it. You will have database at a top level. In database, you will have tables. Tables will have rows. Rows will have columns, and columns will have value. This is relational database world. In MongoDB world, you will have database. Database will have collections. Collections is a table. Collections will have documents. Documents you can think of multiple. I'll not call it as a row, but because MongoDB is a document based store, so each document is a record in itself, right? So table has rows or collection has documents. Now all those documents has fields, and fields will have value. So the example that I was giving here, the employee thing, where employee has ID, name, address, department. So this is my document which you will store in a collection. You will store it in a collection or a table. This is document, and each thing is a field. ID is a field, name is a field, address is a field, and the value of the ID is value of the field is the value. ID will have certain value, name will have certain value, so that those are values. So just to repeat, databases will have collections, collections will have documents, documents will have fields, and fields will have value. So we will talk in this notation only, in this terminology only in the subsequent video. Whenever I'm referring collection, you can think I'm talking about the table. Whenever I'm referring document, you can think I'm talking about a particular record, and then fields and value. So we'll talk in this terminology only in the subsequent video. Now going to the next concept, which is data modeling. So the first thing you need to do in MongoDB is you need to design your data model. Whenever you want to store your data inside MongoDB, you need to do a data modeling, and MongoDB supports two types of data modeling. First is the embedded data models, and the second one is the normalized data models. And what are these two type of data models? Let's take an example of an employee again. So let's say you have an employee which has ID, which has name, which has, let's say, list of addresses, and list could be, let's say, it could be a mailing address, let's say address 1. Address 1 could be, let's say, city, street, anything, and then you have address 2, and then you have address 3. So you can have list of addresses, and then you have a department. Now department, let's say this is also a list where some employees can belong to one department and some employees can belong to multiple departments also. So let's say it's a department 1, department 2, like this. This is your document which you want to store. Now let's say if you have to data model this kind of a structure for your MongoDB, there are two approaches. So embedded data model is something where you want to store the data in an embedded format only. So that means address is embedded within this document only. Departments are embedded within this document only. So you will store the complete JSON document as it is, and that is called embedded data models. So this is called embedded data models when you have the complete document in itself, and you are storing the complete document in MongoDB as it is, with all the relations within the document itself. So that is called embedded data models, or you can, in relational world, this is also called a denormalized form, where you have everything in one row. In one document, you have everything and you are storing it as it is. The second type of data model is normalized data models. In the normalized data model, what you will do is, in the first document, you will store ID, you will store name, and you will store, let's say, a reference of the address. Let's say address, you will say just the reference of this address. Let's say address can be ID1, ID2. Address can also have ID, right? So department can have department ID1, department ID2. So or this is address ID1 or address ID2, right? So you're just saving the IDs of the address and IDs of the department, but the actual addresses and actual departments are stored somewhere else. Or let me make a better representation of this normalized data model. Let's forget about this. So we'll make a better representation of this data model. Let's say in the first document, you're storing only ID and name, and then other details about the employee if there are any. Then in the second collection, you are storing the address. So let's say address has city, street, address line 1, line 2, whatever it is, and then you give the reference of employee ID also here. Employee ID, which is this ID only, you will give the reference here. So this is your address document and this is your employee document. And similarly, you can have department document where you will have again employee ID, which is your ID only. So this ID, and this ID, both, all these three are same, and this is how these are interlinked with each other with the ID notation. Then you can have department name, let's say department ID. You can have multiple attributes related to department. Now these three are different documents. You have normalized these documents, and then these documents can be stored in different collections. So this is a second type of data model where you can extract out different entities and you can save different entities in a normalized way. So this is called normalized data models, and this is called embedded data models. So these two type, this is called embedded data models and this is called normalized data models. So these two type of data models are supported within MongoDB. Now within data models, when you are saving your document, I just wanted to give one overview of one of the concept which is called database reference. So we here you are storing multiple documents in multiple collections. What we discussed at the top level, we have a database, and in database we'll have collections. So let's say in this particular example, one of the collections would be employee, department, and address, right? And all of these collections are in the same database DB, let's say, right? So all of these collections are in the DB database, employee, department, and address. I'm talking about this normalized data model when you have three types of documents are going into three different collections. So you will have three different collections, and all of those are in DB. But you can also have a scenario, let's say inside the database 1, you have employee, Inside the database 2, you have department, and let's say address is also in database 2. So these two collections are in database 2 and this collection is in database 1. So in this case also you can refer employee ID inside the department from database 1 also. So you can have inter-references also among the collections in between different databases. You can reference one collection from one database into another collection in a different database. So this is also possible in MongoDB. It's not necessary that you need to have all the collections inside the one database. You can have the collection inside multiple databases also, and then you can reference the collections within other databases also. So this is possible. So this is the concept of database reference which I wanted to talk you in the data modeling. So whenever you are modeling your data, you can consider this scenario also. So if you want to have your collections in different databases, that is perfectly fine. It is supported within MongoDB. Okay, so we talked about data modeling. Now the next thing we are going to cover is that what all operations are supported within database, MongoDB database. So we'll talk about database operations, what all you can do in MongoDB. We are not going into the syntax in this, like how you can do this, but what I'm going to tell you is that what you can do is, so you can create your database, you can drop your database. So the first thing you will have to do is create your database whenever you have to start with MongoDB, right? The next thing would be you can create your collections. You can create your collection or you can create your table. You can drop your collection or you can remove your collections. So you can drop your collection. So once your collection is created, after that you can insert the documents. You can update the documents. You can delete the documents. You can save the documents. So insert and save in a way are similar, but insert is mainly to insert the new records, but save will handle both. It will handle insert as well as update. So if the record for that particular key is already, for the particular ID is already existing, it will update that record. If it's not existing, it will insert that record. So save in a way, it's a combination of insert and update. Now you have other operations. Let's say you can projection is allowed within MongoDB database. What is projection? Let's say you have 10 fields in your document and you want to select only particular 3 fields. You can project those particular 3 fields. In a relational database, let's say you have to select only particular 3 columns from a table. Out of 50 columns, you have to select only 3 columns. So that is called projections. You can do projections in MongoDB also. Then you have limiting concept where you can limit number of output records, and then you have sorting thing where you can sort the results based on a particular field in ascending or descending order. So all of these operations are supported within MongoDB, and there are certain other operations related to these things: insert, update, delete, save. That there are some additional functions available. Let's say if you want to insert only one record, there is insert one function available. If you want to insert many records, there are insert many function available. Similar with update, delete, update one, update many, delete one, delete many, save one, save many. So these are additional functions where you just want to ensure whether you are inserting only one document versus you are inserting many documents. So you can use these functions also, or you can use these functions also. Either of the ways, it's fine. It depends like how you want to what all things you want to ensure within your project, and you can use the appropriate function. So these are all the basic operations supported within database: creating databases, creating collections, inserting, updating, deleting, saving, projections, limiting, and sorting. Okay, so this was about database operations. Now we'll talk about aggregations. Within MongoDB, you can aggregate your data also. So aggregations is supported within MongoDB. So let's say you have multiple employees you have multiple employees where employee has ID, name, addresses, department, and let's say salary is also there. And you want to, let's say, find out employees whose salary is greater than, or for example, you want to find the sum of a salary of employees in a particular department. So in this case, you have to do group by, as well as you'll have to do sum of the salary also in a particular department for all the employees, right? So this is the aggregation operation, and this kind of operations are completely supported within MongoDB. So there are a bunch of functions available in terms of sum, average, min, max, and there are a lot of other aggregation functions are also available, which I'm not going to write every function here, but I just wanted to give you an idea that there are aggregation functions available within MongoDB which you can use to aggregate the record or the documents based on a particular field, and you get the result back, the aggregated result back. You can get it. So this is possible in MongoDB. The next concept we'll discuss about is the indexing. So now we are moving towards certain advanced topic. We have covered the basic things. Now we'll discuss certain advanced topics now. So indexing. What is indexing? So indexing is, again, going back to the document. Let's say we have employee ID, we have name, we have salary, we have addresses, and we have departments. So let's say this is my document, right? Now indexing is, let's say, defining a way that how you want to query your data. Let's say you want to query your data based on name, based on ID. You want to query your data based on particular city in the address field. You want to query based on particular department in the department field. So how you want to query the data. So that is called indexing, and MongoDB has different type of indexing options available, which we are going to discuss now. So first we will discuss is the default indexing, which is _ID index. So whenever you insert your data inside MongoDB, so there is an object ID associated with that document. Whenever you insert the data inside a MongoDB, it will always be associated with object ID, and that is within the field name _ID. So let's say whenever you are going to insert this document into MongoDB, so MongoDB will assign _ID field. It will add this field in your document, and it will give some 12 digit or 12 byte value to this, which would be a unique ID for this document. So this unique ID, you can give yourself also. You can tell MongoDB that you want to provide some explicit value to this ID, but if you don't provide your explicit 12 byte value, MongoDB will auto create it for you, and it will store this document with this ID. Now by default, the indexing happens on this ID. So you can query your data based on this ID. Let's say if you have given your own ID, let's say your employee ID is 12 byte, and you want to make employee ID as a object ID, then you can assign employee ID to _ID field, and it would be auto indexed within your MongoDB. And then later on you want to query your data based on employee ID or this _ID field, the results would be faster because this column is this field is already indexed within your MongoDB. So this is the concept of object ID, which is the default index within MongoDB, and this is a mandatory column. You can give your own value, or you can let MongoDB to create this value for your document. Both things are supported. Second type of index is the single field index. Single field index. So single field index is that out of multiple fields in your documents, you can pick any one field and you can create index on that field in your document. Let's say I want to index my data based on a name, so that I can query the data based on a name later on. So this way you can pick any single field from your document and you can define indexing on that. So that is called single field index. Third is compound index. So compound index is, let's say, if you want to query your data based on multiple fields, you want to query the data based on name, you want to query the data based on, let's say, city in the address, you want to query based on department name in the address. So let's say this address has city, street, and department has department name and department ID, let's say. So you want to define compound index in terms of first index could be, let's say, name, and second index could be this city. So you want to define index based on these two fields. So then in that case it would be called compound index, and in that case you can query the data either based on name or based on city. So whenever you are querying based on these two columns, your search results would be faster because the data is already indexed based on this compound index. Another type of index is the geospatial index. So geospatial index, it's a special kind of index if you have to make queries on your data based on the geolocation or the coordinates of the of any particular data record. So for that, it supports a geospatial index, and this is specific to use cases where you want to do searching based on a location or the geo coordinates of a person. So this kind of index is also supported within MongoDB. And then in the last, I want to talk about one more important index, which is text index. Now let's say for this text index, it's kind of a index where you want to enable text searching within your document, right? So let's say in this employee document only, you have one column where let's say it says description, which could be, let's say, employee description, and it says it's a text, right? It's a long text, and you want to enable searching. On based on certain key patterns within that description. So you can enable that using text index. So it supports multiple regex patterns. So using those regex patterns, you can do text searching within your document on a particular field if that field is indexed using text index. So this is also supported within MongoDB. And one more thing, one last index I would like to talk about is the multikey index. Multikey index. So this is again a special type of index which you can enable for array type of elements. Now this is applicable for cases where you have a field as an array and you want to search based on any key within that array. Just a practical scenario, let's say you might, let me write down here, let's say you are building a blogging application, and in the blog you have multiple blogs, right? You have a blog ID, you have a name of the blog or a title of the blog, you have the complete blog document, and let's say you want to define a tags also to the blog. Now this tags could be array. You have tag, let's say it could be, let's say first tag could be health, second tag could be, let's say it could be anything, let's say specific to any food. It could be any type of tags, right? Now let's say later on you want to enable searching. Let's say whenever you want to search based on health tag, you want to get all the documents which is tagged to this health tags. So this health is inside array, so you can enable array indexers also in MongoDB, and this is called multikey indexing. So any document which you have enabled multi-key indexing based on some certain array, which is a tags array. So all these keys, health, food, will be indexed, and you would be able to query your data based on any value inside those tags or inside those arrays. So this is multi-key indexes. So this is also supported. So we talked about multiple indexes, the default ID index, then we talked about single field index, compound index, geospatial index, text index, and in the last multi-key index. So these are all the indexes which you can define on your documents. You can create the indexes, you can drop the indexes also. So both operations are supported within MongoDB. The next thing we are going to talk about is the replication. So replication, it's a strategy within your MongoDB to make sure that your data is safe. It is a data safety strategy within your MongoDB server. Let's say you have a one node where your data is there. So this is a MongoDB node where you have a data. You are reading the data here from here and writing the data from here on this node, right? You have this MongoDB node. Now, in order to make sure that your data is safe, you can create replica of your data in another node also. This is node 2, this is node 1. So you can define that how many replicas you need for your data set. If you have defined 3 replicas, so you can have 2 additional nodes which will have your data, right? So you can enable replication in your data. When you enable replication in your data, you will always be reading and writing to this node only. So this is your primary node. So you will always be communicating with the primary node, but these additional nodes, node 2 and node 3, these are the backup nodes. So these are the backup nodes. So in case something goes wrong with the primary node, then you can query your data or insert your data inside secondary node. So these will become active at that point. So you will have automatic failover handled. You will be having automatic failover scenarios handled if you have replication enabled. You will not see any failovers. You will switch from primary to secondary nodes in case something goes wrong with primary. So this is again a mechanism to ensure that your data is safe. It's highly available. So you are making your MongoDB server as highly available. You are also making it ready for the DR scenario, disaster recovery scenario. Let's say in particular data center where this node was there, node 1 was there, some disaster happened there. So in that case also, you can make your secondary node available for query purpose. So you need to ensure the zone set strategy also, so that all of the nodes are not in the data in the same data center. So you can have some of the nodes in some other data center to ensure that you have disaster recovery process also covered, and it will ensure that you have no downtime. So in case your server goes down, the primary server goes down, you don't have any downtime because your secondary server is still up, and you can communicate with that for reading and writing the documents. So this is the concept of replication which is supported within MongoDB. The next thing we are going to talk about is the concept of sharding. So MongoDB is highly performant database. But what about those cases when your data size becomes too large? When your data size becomes too large, in those cases, having all the documents in one node doesn't make a sense, because to query the data and to write the data, the performance can be a challenge in those scenarios when your data size is large. So when your data size is large, and let's say this node has 1 TB of storage, and your data size is more than 1 TB, what will you do in that scenario? In those scenarios, you will shard your data. And what is the meaning of shard? Shard means you will distribute your data across multiple nodes. So you will have another node, node 2, and you will have node 1 here, and your data would be distributed. Some of the data would be there on node 1 and some of the data would be there on node 2. And this is how you can distribute your data among different shards. So this is my shard 1, this is my shard 2, and your data is distributed among 2 different shards. And this is how you can achieve horizontal scaling also. horizontal scaling. What I mean by horizontal scaling, it means that as and when your data keeps on growing, you can keep on adding more and more shards, and then your data would be distributed. Now your data is distributed, but how the overall structure will look like is, because now you'll have to make the queries also. Now which node you will make the query, this shard1 node or the shard2 node, because your data is there on both the nodes. How the query mechanism will work now? So in those cases, MongoDB has another concept, which is a concept of a router. So you will have multiple routers on the top. So let's say this is my router 1, this is my router 2. So you will always make your queries to a router. So let's say this is my router layer. So you will always make a query to your router, and then you have config servers. So config servers, let's say these are the servers which maintains the metadata that what all nodes you have your data on. So this will have the information. You will make your query to query server or a router. Then this router will communicate with this config server, and it will get the information like where your data is. And once this information is there, then it will make the query on that particular nodes. And then on those nodes, data would be fetched to the router and data would be returned. So all of these nodes are interconnected to each other. All of these nodes are communicating with each other. But the only difference is that whenever any client is going to make the query on the MongoDB, it's always going to make the query onto the router layer, or this is also called the app layer. So your client is always going to talk to the app layer, and app layer will communicate with this config server. And then based on the information available in the config server, it will get the data from a particular shard, and then your query will run on those particular shards. It will combine the data point, and then the data points would be, your query results will be returned back to the client. So this is how this overall architecture works in case of a sharding. So again, just to highlight what is the benefit of sharding, that you can achieve horizontal scaling. You are not dependent on the disk space of one node only. You can have the data more than the size of that particular node. And then if that is the scenario, you can distribute your data among multiple shards, among multiple nodes, and then you can query the data in a distributed way. So you can achieve distribution of data using the sharding concept. Now we'll talk about sharding strategy, that how you can implement sharding. So we'll talk about sharding strategy. So what is sharding strategy? So we talked about that you can distribute, here we have talked about that you can distribute data among multiple nodes. This is node 1, node 2. So let me make these nodes again. This is my node 1, node 2, and let's assume there are 3 nodes, 1, 2, 3. This is my shard 1, shard 2, and shard 3. So any new document, whenever you are inserting, how you want to distribute your data, whether it should go to shard 1 or shard 2 or shard 3. So if you want to have this kind of strategy, this is called sharding strategy, and there are multiple strategies available within MongoDB. So first is the hashed strategy. Hash strategy is that in your document, you can define a particular field which you want to hash, and based on the hash value, the data will go to a particular node. So this is called hash strategy. It's straightforward. Just calculate the hash value of a particular key, particular field, and based on the hash value, it will go to a particular node. It could be either 1, 2, or 3. Second would be ranged strategy. So ranged shard strategy is that you want to assign particular range of documents. So particular range of a particular field in those documents that you want to assign, and those ranges will go to particular shards only. Let's say shard 1 will have, let's say you have a ID column, and you want to say that ID 1 to 1000 will go to here, and 1000 to 2000 will go here, and 2000 to 3000 will go here. So you can have a ranged strategy also on your document, that you can define a range on a particular field, and the document would be distributed based on a certain range. Or so this is how the range strategy works. I hope this is clear. So one we have a hash strategy, and another we have the range strategy, range sharding, where your data is going to a particular node based on the range value, where this particular document is lying into in that range. So this is the concept of sharding strategy which you can have within your MongoDB. Now we'll talk about some of other concepts. Let's say we'll talk about capped collections. Capped collections. Now what is capped collections? I hope you remember, you know what collection is now, right? Collection is in relational database, if you have to relate it, it's a table. Capped collection is, let's say you have a table or a collection in your MongoDB. Let's say it's a employee collection only, where you have ID, name, department, and you want to cap your collection, and you want to cap your collection in multiple ways. Let's say first way is you want to cap your collection or table based on size, that the maximum size you want to have for your table is, let's say, 1 GB. Beyond 1 GB, you don't want to insert any data. If anybody tries to put the data more than 1 GB, then older records will be removed from the collection. Second type of capped collection could be based on the number of records. Let's say you want to say that I just want to have 1000 records in my table. Beyond 1000 records, the older records would be evicted. So this is the number of records. And third capped collection could be based on time to live, TTL. So you can define certain expiry time on your records, and after that time the records would be expired. It would be removed from your collection. Let's say you have defined 1 hour of TTL. So after 1 hour, any data which is older than 1 hour will be removed. So these kind of concept you can enable on your collection, on your table, and then your collection will behave in that way only. Now, why this is required? These are required in multiple use cases. Let's say you want to enable caching. So you want to enable caching where you want to either have, let's say, 1000 records only, or you want to have 1 hour of data only in your table. So you can implement caching strategy using this capped collection mechanism, or you want to have caching based on certain size only, that you just want to have let's say 100 MB of data in your table or in your collection. So you can implement caching strategies, or there are particular use cases where you need to have these kinds of features. So these features are provided out of the box within MongoDB. It's just a configuration that you can enable on your collection while creating the collection, and then it would be provided to you out of the box. So this is about capped collection. The last topic that I want to discuss in MongoDB is rockmongo. Now we have understood all the concepts of MongoDB. So rockmongo it's a kind of a administrative UI you can think of, or a tool, administrative UI tool, which you can open and you can do many operations using rockmongo. Let's say you want to create your database, delete your database, all of the database operation, query your database, all of those things can be done as a admin user via rockmongo. So you can think of rockmongo as an administrative tool for your MongoDB, which helps you to enable multiple operations through a single interface of rockmongo. And as I mentioned, you can create new databases, create new tables, insert the documents, query the documents directly from the rockmongo also through this administrative tool. So this is kind of a utility which is on top of MongoDB, which adds to the feature of MongoDB. So this is the last concept which I wanted to cover for MongoDB. Quick recap. So we'll do a quick recap on what we have learned in MongoDB. So we started with what is MongoDB, NoSQL database, schemaless database. Then we went into features and benefits. You don't need complex joins, scalable. It's a schemaless. We talked about all the features. Then we discussed about terminologies, which is that we have a database. Inside database, we have collections, we have documents. Documents has fields and fields has values. Then we talked about the data modeling, which is embedded data modeling, where you have the complete document stored as it is, or you can normalize your data into multiple collections, and different collections can be part of one database and different database, and you can refer those collections out of the box within MongoDB. Then we discuss about different operations. creating the database, creating tables, dropping the tables, inserting, update, delete, save, projections, limiting your records, sorting your records. Then we talked about aggregations, which is sum, average, mean, max, and many other operations supported within MongoDB. Then we talked about different indexes, let's say object ID, the default object ID, single field index, multiple field index, array based index, text based index, geolocation based index. All of those indexes are supported within MongoDB. Then we talked about replication, which is to make sure that your data is safe. You can enable replicas of your data, of your nodes, MongoDB nodes. And then we talked about sharding. Let's say if you want to distribute your data among multiple nodes, then you can implement sharding within your MongoDB cluster, and then you can distribute your data based on multiple sharding strategy. It could be hash strategy or it could be range strategy. Then we talked about how you can implement caching using capped collections, using the size concept or a number of record limitations or expiry of your records. And then in the last, we talked about the rockmongo, which is the administrative tool for MongoDB. So that's all which I wanted to cover. I hope you got the basic concepts of MongoDB, and we talked about certain advanced concepts also in terms of indexing, sharding, application. If you like this video, do press the like button, do share this video with others, and do subscribe LimeGuru channel to support us. Thank you.